Out there in the vast darkness of space, beyond the familiar glow of our sun, wander solitary planets. Astronomers call them rogue planets, and they are fascinating objects. These planets don't orbit a star. They drift through the galaxy alone, shrouded in perpetual night. What makes a planet go rogue? It's a tale of cosmic upheaval. Imagine a young solar system, still chaotic in forming. Gravitational interactions between planets can be like a game of cosmic billiards. Sometimes a planet gets ejected, flung out of its system to wander the galaxy alone. It's a dramatic event, but astronomers believe it's happened countless times in the universe's history. These rogue planets are incredibly difficult to detect. They emit no light of their own, and they are often very far away. But astronomers have found a few, and their existence hints at a universe teeming with more planets than we can imagine, many of them adrift in the vast emptiness. Our solar system, a well-ordered dance of planets around the sun, seems stable and unchanging. But this cosmic ballet is not immune to outside influences. What would happen if a rogue planet, cast out from some distant star system, wandered too close to our own? Imagine this. A rogue planet, larger than Jupiter, enters our solar system from above the plane of the planets. It would be a silent arrival at first, invisible to the naked eye. But its massive gravity would begin to tug at the outer edges of our solar system, perturbing the orbits of comets in the distant Oort cloud. As it draws closer, the rogue planet's path would be influenced by the sun's gravity. It might take a hyperbolic path, slingshotting around the sun and then exiting our solar system as quickly as it entered. Or it could be captured by the sun's gravity, settling into a distant and highly elliptical orbit. A rogue planet entering our solar system wouldn't be a case of simply squeezing into a cosmic parking space. Its gravity would be a disruptive force, potentially throwing the entire solar system into disarray. The extent of this disruption would depend on the rogue planet's size, trajectory, and how long it lingers. The most immediate effects would be felt in the outer solar system. The orbits of the gas giants, Jupiter, Saturn, Uranus, and Neptune could be significantly altered. These planets, though massive, are sensitive to gravitational nudges. Over time, these orbital disturbances could cascade inward, affecting the inner rocky planets, including Earth. Even a slight shift in Earth's orbit could have dramatic consequences for our climate and the delicate balance that makes life possible. The arrival of a rogue planet in our solar system is a scenario with a wide range of potential outcomes, some benign, others catastrophic. If the rogue planet is small and passes through quickly, its gravitational influence might be minimal, causing little more than a cosmic ripple. However, a more massive rogue planet lingering in our solar system could have profound consequences. It could disrupt the asteroid belt, sending showers of asteroids hurtling towards the inner planets, including Earth. It could even eject planets from the solar system entirely, scattering them into the interstellar void. While a direct collision with Earth is unlikely, the gravitational effects alone could be devastating, potentially rendering our planet uninhabitable. The likelihood of such an event is thankfully very low. Our solar system is relatively stable, and encounters with rogue planets are thought to be extremely rare.